let's go on to section 6 on probability. So the generic concepts and terminology we'll go over first. And so let's get started. So what do you think of when you hear probability? You may maybe consider, like, what we're going to consider mostly is like a coin toss, or like a 6-sided die. And this is the simplest way to explain it, right? What's the probability of something to occur? And we want to define things in the simplest fashion first, and then from there it takes off to all kinds of fields of study and things like that. So let's consider that. So suppose you have a coin toss, and the outcome is either a heads or a tails, right? So you toss a coin, fair-sided coin is what they usually say, and it's either heads or tails. And after, in tosses, so after a certain number of tosses, what would be the expected outcome? And that's one of the things we talk about, is the expected outcome of these events. So the expected outcome would be half heads and half tails. That has to be true, or must be true, if it's a fair-sided coin, right? If it's actually going to be a fair-sided coin, that's what must be true. So that's what we would expect. Okay, so we define a few things. An experiment is a process by which an observation or measurement is obtained. So that's the experiment. So that seems kind of maybe loose, like not quite well defined. What do we mean by that? It's like, well, you're going to actually like toss a coin, and that's the experiment, or run some sort of case to see what happens. All right, so that's what you get. So here's an example. So suppose you have something like this. So some examples are recording heads or tails of a coin toss. Okay, so that's the experiment. Two, and it's all recording something, or all doing something. Two, recording like a die, you toss a die, 1 through 6 of a die toss. Okay, so that could be the experiment. 3, the experiment could be like, now we're going to something totally different, like snowfall. So what's the depth of snowfall on that day? That's the experiment. Okay, so snowfall depth. 4, we're all used to this, recording exam grades. So any of these things are considered an experiment. Then let's talk about, we're going to break that down even further. The next definition we're going to talk about, excuse me, is a simple event. So a simple event is the outcome of one repetition of an experiment. So the experiment might be defined to be throwing or rolling a die 10 times, or flipping a coin 5 times. A simple event is specifically basically one case of the experiment. So a simple event is the outcome of one repetition of an experiment. Okay, so for example, a die toss or a coin toss or something like that. So I think I picked die toss. So a die toss. So, and we often label those with an E, E1, E2. So E1 for a die toss, let's suppose you do the die toss and you get a 1. Okay, and then you do it again, we'll call that E2, you record that and you get, say, a 3. And then E3, you record that and say you get a 4. You could just picture rolling a die and you record that. So each of these cases, so each of these, so each is a simple event. And then an event is the whole thing, basically. An event is a set of simple events. Okay, so here's the next definition. An event is a set of simple events. And so we can define this or write this in notation or in a set notation. So we can say A is the set, and it's the set of E1, E2, and E3 from above. Okay, so that's from the previous one. And so we can look at that whole, what is the probability of rolling a 1, 3, and a 4? Like that's what we can talk about, and we will define that. So let's see. So here's an example, and we'll do a die toss again. So we're going to restrict the simplest explanations to basically coin tosses and die tosses. And then we can talk about other cases, but that's, this kind of one we all can visualize. So suppose you have a die, and I'm going to actually draw a three-dimensional representation of that. This is how you do it. Let's see if I can make it better. So once you get a box like that, then you can duplicate it and move it like that, and then you erase it and you make it look like a three-dimensional thing. Okay, so let's get rid of that. And you go, you need to keep drawing, so go like that, like that, like that. And then like that, and then so you can't really see the perspective when you do it like that, so you need to erase or make the other sides dotted. So I'll just do that by hand, making it dotted. So we're going to make this dotted. So this is the back. So now it kind of looks more like a cube. So that's your die. So let's label that. We'll label the front 1, and then this might be 2, this might be 3, the bottom 4, you get the idea, 5, 6. So you have then 1, 2, 3, 4, that would be 5, and then 6 would be in the back. So you get that concept. Okay, so that's so what you can write out is the number of possibilities. You can roll a 1, a 2, 3, 4, 5, or 6. So an event, as from above, So the event, not a simple event. A simple event is rolling one of them. Like you just roll it and see what you get. The event, as I defined above, was rolling okay, I'm redoing it. So this is a little slightly different. So suppose let's call it B. Suppose B is the event of rolling a 2, 4, 6. So those are like even numbers, right? So these are basically 3 simple events. We're not talking about probability yet. We're just defining the event of doing something. Okay. And then we can describe, say C is the set N such that N is less than or equal to 4. Well, that would be 1, 2, 3, 4. And so another way to describe a simple event. So if N is the event rolling the die, what is the set of N less than or equal to 4? Well, it would be 1 through 4. We still got 5, 6 in there, right? But that's all you would get. Okay, so suppose you have those two events, okay, B and C. So we say the events B and C are not mutually exclusive. Excuse me, mutually exclusive events. They are not, because there's something in common. So we say events B and C are not mutually exclusive. Since there are two outcomes in common. So since there are two outcomes in common. Which is 2 and 4. Okay, so these two outcomes in common, let's do this, so the 2 and the 4 are both in those events, so they're not mutually exclusive. All right, so then let's define that concept of mutually exclusive. So here's a definition, which kind of guess what it might be from this. Two events are mutually exclusive if when one occurs, the other cannot occur, or vice versa. So two events are mutually exclusive if when one occurs, the other cannot. And vice versa. Meaning, if the other one occurs, then that one can't, right? So it's so if one event occurs, the other one cannot occur. Okay, so that's what we mean by mutually exclusive. And these are not, because you have events in common. So if C occurred, it is possible that B occurred as well. And we'll get into that a little bit, but we don't want to dive too deep into it. it gets pretty crazy and complicated. And we're just, like I mentioned, we're kind of hitting the surface of all this stuff. Okay, so let's talk about the next concept, and that's the big picture. The set of all simple events. So you take all simple events, in which I wrote down actually up here. This would be all of the simple events for rolling a die. So this set is called the sample space. So here's the definition. So the set of all simple events excuse me, so the set of all simple events is called the sample space. And we use S, sometimes like a cursive S. Okay. So let's change gears a little bit and let's talk about a coin toss. So, example. Let's do the sample space for 2 coin tosses. Like, what are all the possibilities? So sample space for 2 coin tosses. So you toss a coin once, and you're either going to get a heads or a tails. We all agree with that. And then you toss it again. Suppose you got a heads first. Toss it again, you're either going to get a heads or a tails. Okay, now go back. Suppose the first toss you got a tails, then you toss it again. Then if you toss it again, you're either going to get a heads or a tails. So the sample space, we say S is equal to what possibilities? And you basically look like this. So the sample space of 2 coin tosses is 2 heads, a heads and a tails, a heads and a heads. Sorry, I mean tails and a heads, or tails and a tails. So you look at those cases. So you write it out like that. You just say H, a heads, heads, a heads, tails, a tails, heads, or a tails, tails. Right? Makes sense? So that's all the possibilities of 2 coin tosses. Let's go to our other example we'll be using, and that is the die toss. So let's list the sample space for 2 die tosses. So 2 tosses of 1 die, not 2 die. That's going to complicate things even more. Okay, so let's list that out. So you can either roll, when you roll it, you're going to roll a 1, 2, 3, 4, 5, or 6. And then each time, each one of those you roll again, you get the same possibilities. You're going to roll a 1, 2, 3, 4, 5, or 6. So you basically have to list out all of these possibilities. That's your first case. That's your second case, right? You list all of those out, and I'm not going to actually list them all out. You can get the idea. So your sample space, although let me move this over, is going to be S equal to, and this isn't 11, you're going to roll a 1, 1. So it's a 1, 1, a 1, 2, right, all the way to 1, 6. And then you do 2, 1, 2, 2, all the way to 2, 6. Right, see how I'm writing that out? Okay, etc. And then you get to 6, and you're going to be 6, 1, 6, 2, all the way to 6, 6. That's how many. So how many are there? How many are there? So what's the size of the set? What's the size or number of elements in the sample space is one way to say that. Okay, well, this is how you do it. You have 6 possibilities here, and then after you've done that, you still have 6 more possibilities. So it ends up being the product of those two. Okay, so it ends up being 6 times 6 is equal to 36. So the size of that set S is 36. Okay, oops, I forgot to write the 6. 36. Okay, and we'll do that more later. Talk about counting rules.